Hello, 8th graders. We are starting our first of 3 astronomy books right now. So I will post under iBooks on our Google Classroom Coda's Earth, Moon, and Sun. And if we scroll down to the table of contents here, you can see that we've got 6 chapters. And these all have to do with the relationship between the Sun, Earth, and Moon. Okay, so how those 3 celestial spheres, so I say celestial, we'll say celestial spheres a lot. It's kind of a tongue twister. But when we're talking about any of the planets or their moons or any sort of natural satellite, they are spheres in space, celestial spheres. Okay, so it is the relationship between those 3 celestial spheres that causes seasons, moon phases, eclipses, and tides. Okay, so this is our first unit of astronomy. We're really kind of zoomed in to just our little spot in our solar neighborhood, okay? And then we're going to zoom out. The next unit is going to be of all the planets and their moons, and then out into the outer reaches of space. Okay, so today we're just going to talk about Earth's rotation, starting with chapter 1. And there's this picture of this cute lady who is in a town that is familiar just based on the structure right here. You guys know that as the Eiffel Tower. And I start out there because in Italy, there is another big landmark there. It's not just sorry, not Italy, France. In France, it's not just the Eiffel Tower there, but we also have something called Focult's pendulum. Okay, well, who was Leon Focult? In 1851, he was a French scientist, and he took a big iron sphere and he hung it from a wire. Okay, so he started this sphere swinging like a pendulum, and it appeared to move direction throughout the day. Well, we know Newton's laws say that an object in motion will stay in motion until an equal or opposite force acts against it, right? So a pendulum should continue swinging along the same plane unless something bumps it to make it move in a different way, right? Well, nothing bumped it, but it appeared that it was swinging out at a different angle. And what he realized was that it is the Earth that is moving underneath that pendulum, that is rotating underneath that pendulum. And so now we have Focult's pendulum in the Pantheon in Paris, France. So you've got this steel ball that is hanging from the ceiling, and it's on a swivel. Okay, so it can move. It's, operated to swing constantly, and it's in a straight line. It constantly swings in a straight line, but it tells time on this 24-hour clock because the clock is actually moving with the Earth underneath the pendulum. So if you're ever in Paris, you can go to the Pantheon and see Focult's pendulum and then send me a postcard or something. All right, so let's imagine an imaginary line passing through the center of the Earth that goes through both the North Pole and the South Pole. This imaginary line is called Earth's axis, and Earth spins on that axis just like a top spins on its spindle. That spinning is called rotation. Okay, that's different from revolving. Revolving is to move around another object in orbit. To rotate is to spin on an axis. An observer in space will see that the Earth requires roughly 24 hours to make one complete rotation on its axis. We are spinning really, 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 really fast. It says here at the equator, the Earth rotates at a speed of about 1,700 kilometers per hour. And that decreases from the equator up to the poles, right? Because there's less area. We have to the whole thing has to move around in less space if you're up at the poles. From nearly all points on Earth, the sun appears to move across the sky from east to west. Of course, the sun is not moving from east to west at all. The Earth is actually rotating. And the moon and the stars also seem to rise in the east and set in the west. It was a really long time in our history. We'll talk a little bit more about some historical astronomers, but way back in the day, when people were wearing togas and sandals around, back in the days of some early philosophers, people believed that everything revolved around the Earth. The Earth was central, it was in the middle, and the sun revolved around us, and the stars revolved around us. And it wasn't because they were uneducated, it was because they did not have the tools to know any differently. And all they could use to make their observation was their eyes. Well, what did they see? They looked outside, they saw the sun come up in the east and set in the west, and it seemed really kind of like a well, duh kind of a thing that, oh, the sun is revolving around the Earth. It wasn't until many years later that we realized that that was inaccurate, and we are actually rotating on an axis and revolving around the sun. All right, so we are going to be defining a few different terms. The first term is going to be day. I know that you guys all know what a day is, but let's try to define the word day in terms of astronomy. Okay, so if we know that the Earth rotates on its axis once every 24 hours, then a day would be the time it takes for Earth to rotate once on its axis. Okay, so what if I threw the word year at you? What is a year in terms of astronomy? The time it takes for what to do what? Think about that. Okay. There is one question. I'm going to post a little video, and the question is, why does Earth spin? Why are we rotating on an axis? What started that movement to begin with? Okay. We will, in Zoom class, we will be defining a couple vocabulary terms. Okay. And I want you to just watch that video and answer that question, and I will talk to you soon.